Hello, welcome everyone to our presentation. The title of our presentation is The Power of the CPU. This is a CPU dataset, and we're going to do analysis on it. I'm Ricardo Diaz, and together with my colleague, we are going to analyze the vast dataset to understand more about the CPU performances, trends, and the benchmarks.
Hi, I'm Rika Crown. We're excited to share our findings from the Spring 2024 Stats Project using data from Kaggle's CPU Benchmarks compilation. Our analysis covers a broad spectrum of different CPUs.
So, starting with the abstract.
So today we'll explore the evolution of CPU performance by analyzing benchmarks of 1,967 CPUs. Our analysis includes various attributes such as price, core count, and TDP.
Our key findings reveal a moderate positive correlation between the CPU price and performance, alongside a noticeable trend in CPU efficiency, improvements over time, and we're going to discuss all these trends and their implications more in depth as we go along the uh, presentation. But also, just going to say that we also did a time series analysis, which indicates the steady increase of average CPU performance over the years and how this reflects the market. Now, within the next couple of slides, we're going to talk a little bit about the introduction. So let's start with the basics. What is a CPU? CPU, or the central processing unit, acts as the brain of a computer. It executes the program instructions and manages data flow and system and such on.
It's helpful to think of a CPU as the conductor of an orchestra, ensuring all parts of the computer work together harmoniously. This analogy illustrates the pivotal role of the CPU in computing systems.
Now, moving on to our data set and pre-processing of our data.
So, our analysis begins with a comprehensive data set that had at least 4,278 unique values or data points. It contained 14 columns and 14 distinct variables. It was in a CSV file that we found on the Kaggle website. From this data set, we removed any missing values in crucial columns like price and CPU value. Ensuring data quality pre-processing is essential for accurate statistical analysis.
So as Rika mentioned, we eliminated some of the outliers and missing data columns, just so we can work with consistent data. So we also standardized, for example, the test date from numeric to actually a datetime format, and we filled all the missing TDP uh, portion of the data with median values to maintain some sort of consistency. These all help us provide a more reliable foundation for a statistical analysis. And now moving on into more of our introduction with our research questions. The purpose of this analytical project, which is really important with these three questions. Our study is actually driven by three main questions. The first one, which is we are going to investigate then whether there's a noticeable trend in performance over time.
Second, we explore how CPU performance correlates with price points. And third, we analyze if there's a correlation between price and performance across different CPUs. Each question aims to uncover distinct aspects of CPU evolution.
So now moving on to our statistical methods that we employ for this.
So we used 5 distinct statistical methods for this project. Um, One was descriptive statistics, which helped us summarize the data, providing a clear picture of the CPU market landscape.
We also conducted correlation and regression analysis to explore the relationships between variables. We also did some time series and cluster analysis to detect any form of patterns or groupings that could tell us more about the data. And these methods all enabled us to draw some sort of meaningful insights from the data, which we're going to discuss when we talked about our analysis and our results for this. And now moving on more. One of the first things we did is do exploratory data analysis. For example, we did the distribution of the CPU prices, which is one of the columns in our data sets. And just for redundancy and to not do a lot of redundancy. You could do this with all the columns, but we're going to showcase two, which are going to be the distribution of CPU prices and the distribution of the CPU performance cores. But right now, we're going to be talking about the distribution of CPU prices. So in our exploratory data analysis, uh, we can see that the CPU prices, which are predominantly lower with some high price outliers. This distribution is crucial for understanding like any market entry points. So it kind of gives us like the median, the mode, and any other form of descriptive exploratory data analysis. I'll turn it to Rika so she can talk a little bit more about the CPU prices.
Well, this distribution helps us understand the general pricing landscape of CPUs in the market. As Ricardo was saying, it highlights the accessibility of computing power at various price points depending on what's allowed in your budget. And so for this one, similarly, CPU performance scores or CPU marks are mostly lower with fewer high performance models similar to the prior graph, indicating a right skew distribution. This tells us that high performance is not the norm, but rather the exception.
We can see that the skewness that this graph has highlights the rarity of the high performance CPU and sets the stage for further analysis. It really prompts us to like question what drives the performance enhancement in these exceptional cases. Now we're gonna move to more of the analysis we did, and one of the first things we did is the correlation matrix. So for our correlation analysis, we showed a moderate positive correlation, for example. In this case, we can look at the 0.53 between the price and CPU performance. And this, you can suggest that the higher prices often correlate with better performance. This is a finding that is integral to understanding consumer investment in high-ended CPUs. And it's kind of obvious, but we did the analysis on this.
Additionally, we found that core count and TDP positively correlate with performance, aligning with expectations that more cores and higher power lead to better performance. This supports the trend towards multi core architectures in recent CPU designs.
Now moving on to our next part of analysis.
All right, so this is our line progression plot related to trends and average CPU price and performances over time. So, looking at these trends over time, we see some variability in average CPU prices, with peaks possibly influenced by the release of high performance CPUs. These fluctuations reflect market dynamics and technological milestones.
Also, the average CPU mark shows a clear upward trend. This really reflects on the ongoing technological advancements and efficiency improvements. It's fascinating to see how these trends correlate with historical developments in computing technology. And talking about historical developments, we can see here in the graph how the average price in USD dollars is always above the average CPU mark. But when 2021 hits, which is around when COVID happened in 2019 to 2022, we can see that that changed and the trend changed. So now the average price is below the CPU mark, and it's kind of obvious here that happened. Now we also have a scatter plot. And the scatter plot really continues to illustrate these trends. It really emphasizes the relationship between the CPU price over the years, and this is just another way to visualize it. I'll let Rika talk more about this.
So, this visual representation helps us analyze how market dynamics affect CPU prices and performance simultaneously. It offers a clearer view of the economic and technological factors influencing the CPU market.
Now moving to our elbow method for optimal K, which is something that we needed to do in order to further more continue a cluster analysis as the first steps to doing it. Rika's going to explain a little bit more about this.
Using the elbow method for cluster analysis, we determined that three clusters provide a good balance, as indicated by the curve flattening after three clusters. This method is used for identifying natural groupings in our data.
So yeah, this method really helps us just like to optimize for how many number of clusters we want to look for in our data, and selecting the right number of clusters really makes our data or analysis more precise and meaningful for the type of CPU types. Talking about the cluster analysis, the next slide is working on the cluster analysis and doing it. And what we did is that we identified three distinct groups: cluster 0, cluster 1, and cluster 2. And for example, cluster 0 contains the mainstream consumer grade CPUs with watermarks and fewer cores. So basically, this cluster represents the most accessible segment of the market, and cluster 0 is pinpointed with the purple points in this scatter plot. And I'll let Rika talk about the other two clusters.
So cluster one is the kind of teal green points, and it includes high performance server grade CPUs with very high marks and cores, while cluster two represents the mid range to high end consumer or professional CPUs. Each cluster reflects different market needs and technological advancements.
Now we're moving on to our results.
So our results confirm the positive correlation between CPU price and performance and reveals significant performance differences across CPU manufacturers. These insights are invaluable for consumers and manufacturers alike.
So these insights are really crucial for understanding the market trends and really guiding any potential CPU buyer out there. They also help manufacturers like gauge upon their products and stand against the competition. This table kind of represents and gives the results of each of the methods that we use, which is correlation analysis, time series analysis, the regression analysis, and cluster analysis. And how what type of visual graph it gives, and a little bit more about the key insight of each of the analysis. And why is it important? For example, the correlation analysis really highlights the value placed on the higher performance in the market. The time series is the one that demonstrates the technological advancement and economic factors that affect the CPU prices. And for example, the cluster analysis really assists in targeting and target marketing and product development strategies. Now, moving on to our conclusions. So, in conclusion, when we buy a CPU, we want to focus on these 5 points. When buying a CPU, we need to consider both the performance and the price, but we also need to pay attention to efficiency trends, as they're really vital for like any future proofing your investment, which is like you want to future proof it. Our analysis also really provides a roadmap for making informed decisions for any buyer out there.
So we hope this analysis aids you in making more informed decisions and understanding the CPU market better. If you want to go buy a CPU, take those points into consideration. It's essential to consider how these factors will impact your computing needs over time and to value your investment in the future.
So thank you. Now
Yeah,
for
thank
thank
you
you
for
part.
your attention.
Also, please feel free to refer to our data source and methodology listed in our references. In our reference, we have the data set. You can click on it and you can look at the data. And if you want to work with it, feel free to go ahead and download it and do some sort of analysis for yourself. Thank you.
Thank you.